right, let's begin these notes. First directions say to write the expression that represents the area of each rectangle. So we know that to find area, we're going to take the base and we're going to multiply that times the height. So let's look here. On this first one, it says write the expression. It doesn't tell me just what the base is. Write the expression of what is the area. Well, I know I've got the base, and I'm going to multiply that times the height. So let's see, my base is 5 times my height is 4. So that's an expression that represents the area of this rectangle. Okay, so the next one, oh, I got that backwards here. Let me fix that. All right, so the base is red. We're doing the base in red. So let's say that our base here is 7 and our height here is m. Well, what would I say is base times height? I would say 7 times m. And with the letters, just like that, when it's a variable, I can just put them right next to each other. Or I could have written 7.m or 7 with the little x multiplier m. You can put it 7 times m, however you choose for this. Next is my base here is a. And my height is 3. So I know that it's a times 3 or 3a. I could have written 3 times a. Let's see, and then here, my base is x, and my height is x. So I know that I'm going to be dealing with x times x. And x times x we know is just x squared, but x times x. Okay, so that is writing an expression that represents the area. So now we're going to actually find the area of each box in here. Each box. So let's look at this first box. The first box, I've got a base of x and a height of 4. Okay, so I've got my first box is 4 times x, which is just 4x. Okay, and then my second box, well, my base is only 3 wide, and then my height, how high do I know it is? Well, it's the same height as the one next to it, we can tell. So that is going to be that 4 times 3. What is 4 times 3? Well, that's 12. So here I've got 4x, and here I've got 12. All right, let's look at the next one. See the next one, my base. Let's see, the base here is a, and the base here is 9, and they both have a height of 7, right? That's 7 here, and it's 7 there. So let's think about this. I've got 7 times a here, and I've got 7 times 9 there. Well, 7 times a is just 7a, and 7 times 9 is 63. Okay. Our base on number 7 is x for this box, and it's 2 for this box. But then my height is x over here, but then it's also x for this box too. So let's see, what do I have here? For this one, I have x times x. And for this one, I have 2 times x. So x times x is x squared, and this box, 2 times x is just 2x. All right, looks good. So let's kind of move on here. Now we're going to look at writing the expression that represents the total length of each segment. So what is that? We've got a clue here. This is total length, total length. So what are we implying? When we total something up, we add it up, right? So let's look at this here. I've got this piece that's an x, and then I've got this piece that's 9, but I want to know what all of it is together. So I know I'm going to have to add x plus 9. All right. Again, I've got a space called x, and I've got a space that measures 4 all together. Right. And then finally that last one, I've got this space called A, and I want to know the total of what it is when I put it with this space that measures 2. So I have A plus 2. All right, so here, so far, what have we talked about? So far, we've talked about that we multiply when we find that area, right? And here we talked about finding a total length is adding. So we've done both sums and products. So now let's put this together just a little bit. We're going to write the area of each rectangle as the product of the length times the width, and also as the sum of the areas of each box. So if I look at this first one, if I look at the area as a product, well, that's like where I took my x plus 7. So I took this piece here and I said, well, I know part of my length is this and part of my length is that. So to get the total length, I need to add those together. And that's, oh goodness. Let's just erase that piece that we just did. Okay, now, so I'm going to take that together, and that's what this is right here, where I've got my x plus 7. So I had to sum that together. I had to add that together, but now I need to multiply it, right? I need to multiply it by the height, which is 5. So I've got that 5 out there. 5 doesn't just get multiplied times the x or to the 7, but it gets multiplied to the 5 times 7. So what I did is I found the product, okay? But that will give me the complete area of this whole thing, right? It gives me the area of the whole thing. But now let's look at it a little bit differently, okay? Now we're going to look at finding that area as a sum. So meaning that kind of like I'm going to go back up here, like these right here, and I'm going to take, well, what is the area of this first box? And I'm going to add to that the area of the second box to get the area of that whole thing. Well, now let's look at it here. So first, let's say, well, my first one, I've got 5 times x, right? That gives me my 5x. But that's not the whole space. That's just this space, right? I need to add to that my next one, which is the 7 times the 5, right? 7 times 5. Well, what is 7 times 5? 7 times 5 is 35, and I need to add that to it, okay? And now I've got the whole space. So that's my sum. I'm adding them together. So in the first one, I multiplied, and the second one, I'm doing my area. So I'm going to kind of like pump the brakes a little bit, and you guys are going to take a minute to do, well, let's see. I'll get number 12 started with you. I'll do the area as a product on number 12, and then you can do it as a sum. So here, as a product, the first thing I want to do is I want to find, well, I'm looking for base times height, right? Base times height. So what is my height here? Well, my height is x, and my base is this whole thing. This is this piece plus this piece. So this is x plus 12. All right. Now you go ahead and fill in the area as a sum. So finding the area as a sum, I'm going to try and add together the area of this box plus the area of this box to find my total area. So if I'm going to do length times width, or I'm sorry, base times height, I've got x times x here, right? X times x. And here I've got x times 12. So I would write that area as a sum. Well, my first one, x times x, it's x squared. And I'm going to combine with that my 12 times x, which is just 12x. All right, you're gonna do number 13 on your own, so press pause on this video, and then after, when you get it finished, you can go ahead and hit play again, and I will reveal the answer to you. All right, hopefully you took the time to fill that out on your own, that last one. So now let's move on to the last part of this. This last part is what you're going to do for practice. This is going to, once you're finished with this practice, I want you to show it to Mrs. Witt. All right, so I want you to work on using the distributive property to rewrite each expression as a sum. All right, so right now it's written like it is the area where I've got like 4 times x plus 7, and I want to rewrite it as a sum. So I know that if I'm using the distributive property, I know that I can take my 4 times each thing. So 4 times x would give me 4x, and I'm going to combine with that my 4 times 7, which is 28. Okay, so you need to, if you're in class with Mrs. Witt, you will go ahead and just raise your hand and she'll come look at that when you're done. If you are at home for some reason, I want you to take a screenshot of number 14 through number 21, and I want you to go ahead and submit that to Mrs. Witt. And then if you're at home, once you get 14 through 21 done, you can go ahead and continue on to the next page. Okay, now we're going to be factoring using that area model. So I'm looking at this and I see that I have this great big, rectangle right here, right? I have this rectangle. And this rectangle, if I add it all together, this top here is my base, this and this piece, both are my base. And this is my height right here, right? So if I wrote this as a, let's see, what did we call it on the page before? If I wrote the area as a product, I would go ahead and add together what my x and my 6 together. This is, let's see, this is as a product. And this is if I'm writing it as a sum, okay? So here it's a product because I'm multiplying these things together. I'm multiplying the 2. I'm multiplying the 2 times the x plus 6, okay? And then the other one, the sum, well, on that one, what I'm going to do is I'm going to go ahead and do each piece first, okay? I'm going to go ahead and multiply each piece first and then add those pieces together. So here I've got my 2 times my 6 right here. I've got my 2 times my x, 2 times x is 2x. And then here I've got my 2 times my 6 here. 2 times 6, well, that is 12. So if I see that my first rectangle gave me 2x, but I want more than that. I want the whole rectangle, so I need to add to that my 12, which is the area of my second one. Okay? So let's look at this. This next one, this one's a little bit trickier. We don't have quite as much information. All right? So I know that if I take, let's see, if I take this times this thing, I'm going to get 5x. Okay? So 5 times what gives me 5x? Well, that seems fairly easy. It has to be an x, right? 5 times x gives me 5x. All right, and now let's do it again here. I know that I'm going to have my 5 times this thing gives me 20. So 5 times what gives me 20? All right, now I have all that information. If I want to write it as a product, I'm going to take, well, what is the height of that? The height of that is 5. And I want to multiply it times the whole base, the whole length, and that is x plus 4. It's not just x and it's not just 4. It has to include both of those to make it the whole length. But if I wanted to write it as a sum, I would want to write down, well, I'd need to know how much is this first box's area plus the second box's area, right? So my first box's area is 5x, and I need to add to that the area of the second box. Okay. So now looking at the next one, I know that something times something gives me 6x. Well, that can be confusing. Like, do I put the 6 here and the x here? Or, let's see, or do I put the 6 here and the x here? Well, it's kind of hard to tell. So I'm going to need to look further. I know that one of them has the 6 and one of them has an x. So let's say I look at the other box. Well, the other box tells me that whatever I've got here times 8 will give me 48. Well, that makes it a lot clearer. That makes it a whole lot clearer because now I know I can't use the x there. I can't use the x there because if I use the x there, then I'd have, this would be 8x, not 48. So I know my 6 has to go there. So if my 6 goes there, well, that's easy. Now 6 times what gives me 6x? That's just x. So let's look at this. If I wrote this as a product, I would take that height and I would multiply it times the entire base there, the entire width, which is x plus 8. And if I were writing it as a product, I would want to take the area of both boxes and add them together, right? So the first box has an area of 6x and the second box has an area of 48. So I feel like that we should be getting that intuition here, that if we look at the first one, writing it as a product, and we just use our distributive property to take that 6 and multiply it across, we would get 6x plus 48. So this is kind of just another visual representation of why this works and how this works. Okay, let's hit this last one. So right here now, let's see. I know something times, so something here times this x will give me 10x. Well, obviously that has to be 10. And now let's look at, I know that 10, I've already found this to be 10, times something here gives me 30. Well, 30 divided by 10, or you could think 10 times what gives me 30, that's 3. So I know that first I'm going to take my height here, 10 times that full length of the base, x plus 3. But if I write it the other way, I'm going to use my what's inside my boxes, right? What's inside my box? So I know that I'm going to take the area of 10x and I'm going to add to that 30. And we can also see that that's true from our distributing too. My 10 times x would give me 10x and my 10 times 3 would give me 30. So that checks out in more ways than one. All right, so now fill in the missing dimensions from the expression given. All right, this is very similar to the ones that we did above. So I'm gonna want you to do these as your practice and then take a screenshot of it and send it to me. But I'll work on the first one with you. Well, here I can see that this one is written like when we write it as a sum. And when we write it as a sum, that means that's that area inside each box. So I know that this is 5x and this is 35. And it tells me that my short side here is 5. That's what this one tells me. So I know that this is 5. So then I just have to figure out, well, 5 times, let's see, 5 times what gives me 5x? And 5 times what gives me 35. So that tells me these are x and 7. So I can fill that in right here, x plus 7. All right, so I want you to do the rest, number 6 through 10, as a check of your own understanding, and then take a screenshot of it and send it to me if you are not with me in class. Then you may move on. And finally, the last little bit on this page, it says the process of writing a sum or difference as a product of factors is called factoring. So we did this up here when we wrote it as, like right here, when we wrote it this way, what we were really doing was factoring. That's what factoring is, okay? So let's do that down here. I'll do the first one with you, and then I'm gonna want you to do the rest on your own here. So here, what I'm looking for is if these were to be boxes. Let's think of this first one. If these were to be boxes, right? This tells me that 4x is one and 16 is the other, right? Actually, this is a minus, so this is a negative 16. So what I need to know is what's gonna go here, what's gonna go here, and what's gonna go here. Well, I'm looking and I can see that the biggest thing I can pull out of both of those boxes is a 4. Okay, so I'm gonna put my 4 right here because that's the biggest thing I can pull out. So now, 4 times what gives me 4x? Well, that's x. And now 4 times what gives me negative 16? Or you can think of it as negative 16 divided by 4 gives me negative 4. So now I'm going to use this information, my 4 times my x minus 4. That's what I get when I factor over here. 4 times x minus 4. And I can always check that if I want to. What is 4 times x? It is 4x. And what is 4 times negative 4? It is negative 16. So I know that that is correct. And you're going to repeat that for numbers 12, 13, and 14. Take a screenshot of that and send it to me when you're finished. Now there is, there is more work to be done. There's more on that. There's 2 more pages of factoring and whatnot, but for right now, that will be included on a different video. Actually, no. That, I believe, is going to be our next exercise for you to work independently.